Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulillahi Kareem. Solve for the following parameters from the electrical circuit in figure. There is a given figure in which battery, which is consist of two cell here. This plate is positive because it is larger than this and this, so and this plate is negative. This is 100 volt battery, and there is a resistance R1 of 100 ohm, and R2 is 200, R3 is 300, R4 is 400, and R5 is 500. We have to find the total resistance in RT. Total is R resistance total. R total we have to find in first case. So I solve first case. And voltage is V1 and V2. V1 means voltage in R1 between terminals of R1, and voltage in terminal R2 is called V2. Similarly, the currents I1 to I5, I1 current is in the resistance R1. Also, I2 is current in the R2 resistance, and I3 is current is R3, and I4 is current in I4 R4, and I5 is current is I5. First we solve part A. This is total resistance, equivalent resistance. Here we see that these three resistance are in series. So we have to find first the resistance in this branch between C and D. I told equivalent resistance of these three resistances R dash. So I write R dash, because these resistance are in series, so we add directly due to these resistance are in series, because we know that resistance in series we do as directly. Its value of R3 is 300, R5 is 500, and R4 is 400. So our value of R dash is equal to here 1200 ohm. And now we can connect equivalent resistance of these three resistance as R dash. So I again plot I again make this figure with the battery E, which is equal to 100 volt. EMF is 100 volt, and R1, and it is R2, and equivalent resistance of R3, R5, and R4 is I told it R dash. I like this is R dash. R dash value is 1200 ohm. Value of R2 is 200 ohm. R1 is 100 ohm. We are seeing that equivalent resistance between point C and D, we can see that the we can find the equivalent resistance which is equivalent to, because these two resistance are in parallel. These two resistance, because both the terminals joint at C, and second terminal joined at the so these two resistance are in parallel. So resistance between these 2 points I write R double dash. So these two resistance R dash and R2 because these are in parallel resistance. So this value is equal to 1200 and also this value is 200. We have to find the LCM of this, which is equal to 1200 1 upon R double dash. Divide this, we get 1, and also divide by this, we get 6. 1 upon R double dash is equal to 7 upon 1200. If we we want to value of R dash, so we can write it as both sides inverted, divided by 1 equal to R double dash. This value of R double dash, you can divide it, but it is sufficient for us for finding the equivalent resistance, so I will not divide it. And I construct the this circuit by adding these two equivalent resistance. We can put a equivalent resistance R double dash in place of these two combined. So I again draw a figure is 100 EMF volt battery, and here is R1 is resistance between A and C, and between C and D equivalent resistance are double dash. So I put R double dash here, which is equivalent resistance for R2 and R double dash, R dash, sorry. Now we are seeing that only two resistors are remaining which are in a series, so we can find the total resistance RT by adding of R1 and R double dash. Therefore R1 is given 100 ohm, and we have find the value of R double dash is this. Now we have to calculate this by taking LCM 7 and 1. We can make 1 because this is fraction, so make its fraction also, and 1 and 7 LCM is 7. So therefore RT is equal to 7, and 7 divided by 1 we get 7, and multiplied 7 to 100 we get 700. Also 7 divided by this 7 we get 1 multiplied to this value we get 1200. This becomes 1900 upon 7. This is total resistance between A and B. Now we have to find the voltage V1 and V2. This voltage if we find, so we have to find the current in here. The current I is emerged from this battery, which is I1, is a total current. So we can find I1 as directly E upon R. Ohm's by Ohm's law, V is equal to IR. Ohm law for battery E equivalence, because V is equal to EMF of electromotive force of battery, because it is applied to point A and B, which is equal to potential difference EMF, because it is applied to these 2 points. There is no resistance, so voltage is equal to EMF. So we can apply here this formula and get I is equal to E upon R. Here total current I is I1, and value of E is 100, and R is RT here for our figure, and RT is 1900 upon 7, and unit of current is ampere, so I write A, and because 7 is double upon, so 7 is multiplied to 100, and we get the value of cancelling out 20, and I1 is 7 upon 19. What we have to find the voltage between the R1, which is V1. We have to find V, because we know that V is equal to IR according to Ohm's law. We have to find V1. So V1 is equal to I1 into R1. I1 is 7 upon 19, and R is equal to 100. So its unit is volt. You can write simply V here. 700 upon 19 volt. V1 is this, and we have to also find the value of V2. This voltage 100 volt is in this figure, last figure. This 100 volt apply in 2 points, divided between these 2 voltage V1 and V double dash. So we can write as, because these are in series, we can write E as I use this formula, V is equal to V1 plus V double dash. What here V is equal electromotive force E B plus V1 plus ka V1 plus V double dash. V double dash is stand for potential difference between V and C and D, between terminals of R double dash. So this value is 100, and this V1 is 700 upon 19. So we can find the value of V double dash by transposing this term to left hand side. We get 100 minus 700 upon 19 is equal to V double dash. So take LCM 1 and 19. So V double dash is equal to 19 LCM 19 multiplied to 100, and 1 multiplied to 700. So this become 1900 minus 700, which V double dash becomes 1200 upon 19 volt. But it is not our answer, because this voltage is apply in this voltage is applied in CD, but CD is in CD, these 2 resistance are in parallel. Therefore, between CD, this voltage also equal to V2, because between CD, this voltage is between CD, this voltage V2 here, and also V2 here, because these 2 are parallel. So V2 is common, but V2 is V double dash here, which is 1200 upon 19 volt. So I find the value of V1 V2, and also I have find the value of I1 for C section. So we have to find the these values. We can we can find easily value of I2, because because for C part we know that V is equal to IR. By Ohm's law we can find the value of I2, because we know V2 and R2. So I2 is equal to V2 upon V2 upon R2. V2 is equal to 1200 upon 19, and R2 is 200. So I2 is unit is ampere. A 1200 upon 19 into 200 ampere. 20 is cancelled out, and 2 also cancelled. 12 is by 6. So I2 is equal to 6 upon 19 ampere. So we have to find now value of I3 here. We know that in series I3 current equal to I5 current is equal to I4 current. These are equal current, I3, I5, I5 and I4. There is one path, so current is same. So we know that here I3 equal to I4 is equal to I5. So we have to only find only one value of I3. Here we see that this current I1 is distributed in two parts here on the junction C, I2 and I3. Therefore we can say that I1 is equal to I2 plus I3. What I1 is, we have find here 7 upon 19. Already we have find 7 upon 19, and also I2 is equal to 6 upon 19. So we can easily find I3 by transposing this term to left hand side, and we get the value of I3, which is 1 upon. Simply we can find I3 by taking LCM 19, which is like 7 minus 6, 1 upon 19 I3. Or I already said that this is in ampere. Also we know that I4, I5 equal to I3. So these all value equal to 1 upon 19 ampere. Thank you very much indeed for listening. Wa akhru da'wana alhamdulillahi rabbil alamin.